So this is our project for ECM 361 is to use OpenCV to control this robotic arm, you know, precisely to be able to do surgery on a grape, you know, possibly cut it open and then possibly sew it back too. And so that's our project, is to again use OpenCV to control the body, every movement, to pick up a utensil uh, used in surgery and to cut open a grape and then to do and sew it back open or sew it back together. So that is our project. That's what we're going to be doing. So this is our project, the X arm. Trying to move it with the OpenCV, but this is how far we've gone so far. Alright. Nice, so as you can see here, I'm going to show you this code. This is PuTTY, and let me just switch over to the code real quick. So we got these modules being imported. They got the files being imported. EasyHD, HID, which is Easy Human Interface Device, and that just is a file that controls what interface device we're using to talk to the arm, and we are using a USB. So we're going to go down here. When it finds the device, it opens it up, and then we got this print statement that will let us know it's connected to the arm. And right here is the meat actually of the program. Let me go back up. Sorry about that. So right here, as you can see here, we see this command servo move. So the thing with these servos is that the company that made this arm made this controller board to specifically communicate with these servos. Traditionally, you would have these servos and you'd have a library that you can import that would help to for you to talk to these servos via your own commands. But this controller board specifically communicates with these servos and vice versa. And so what we've done is we've got the command protocols, which is one of them right here is command servo move. We've got this command protocol, and then we're able to write this command protocol using a Raspberry Pi rather than what they gave us, which was this PS2 controller and actually another program that they had us install. So if we go down here, we got these bytes being written to the as in an array, and we got this read function that's reading back to the Pi what's going on. Go down here. These are the limits of the of each servo. So like base and wrist, ripper. So we keep going down here. Some complications we ran into. So right here, this is the self move all function. So this is the function I've been tweaking a bit. And if we go down here to demo, this function is just calling all the functions that were described above for each servo. Now, for some reason, this rest function was making it so that the arm would just slam, and that was kind of weird. So I am tweaking the self move function up there so that it made it so I can actually get into a rest position like this. There are still some servos that we got to tweak, like this one and that one and this one, but for the most part that is working. Now where Jackson's code would come in ideally and theoretically is up here in the self that move. Give me a sec. Let me just find this. Okay, almost there. Right here, where we would get the output of the OpenCV code and pass that argument into here, and that would make it so that we can actually control the arm while it's continuously updating in that code. But that is where we are at. That's where we find some complications. But so far, so good, It's a good project.
Okay. So right here, we have the code for the gesture recognition. And so what I've done is I've imported CV2, so our OpenCV, the module for it. And this code is code that I got from a guy that he had a YouTube video and then he posted his code on GitHub. And basically, it's a fully functional code for gesture recognition. And so this is all taken from that source. But then what I've done is I modified the code a little bit and put gestures vector right here. And so I've just started out with everything false. But we also have this these if statements. So these different circumstances here show us that if it recognizes a certain pattern in the gestures, then we'll assign the first item in the vector to true. And then so on and so forth for the other cases. If we have it recognize these contours, then we'll assign that true. And then right here, so far what I have is it's going to print those gestures out, the vector, and we'll see it out here in the terminal window here once I run the code. And then based on whatever code I find, or whatever hand gesture I do, it's going to display that in the vector. So I'll go ahead and run this code. And you can see the vector is constantly updating. I haven't shown it really anything yet, but I'm going to pull up these screens here. We have a thresholded view, and then we have just the view with the box, and then whatever I put in the box is my hand gestures it's going to recognize. So I'll go ahead and do one here. This one's high, so you can see on the screen it's outputting the words high, but of course we'll adjust that how we need to. We'll try and rearrange the contours how we need to get the hand signals that we want to suggest for each servo to move. So here I have high, and then 3. Let's see here. This is a basic hand gesture recognizer, and then 4. This is 4. So you can see we have a little bit of fine tuning to do as far as the vectors go, and then lighting is critical as well. But I'm just going to move these windows over here so that you can see that when I make some new hand motions, you'll see that these update accordingly for each different one. So if I do high, the 4th item there's going true, but if I go back to 3, it's highlighting the 2nd item in the vector, or if I do the 4, the 3rd one. So various combinations will give us what is it going to show true. Yeah, so that's that.